All right, good morning. I'm going to go through, starting on page 200. On pre-calculus 30S on multiplying and dividing radicals. If you have any questions or comments, either put it in the comment box or go to Edmodo and send a private message through Edmodo. So I've got both of those up right now. That way I can see it kind of as live as we can get it. I know it's not ideal. Some of you can text. All right. Okay, I'm just checking online here, make sure. All right, so last day we just looked at radicals, changing radicals. Today we're going to look at actually multiplying and dividing radicals. So I'll follow through the examples in your book to begin with. The biggest thing that we have to remember with radicals is we have to treat them a little bit like fractions in the sense that we want to always break them down into their base units, or as small as you can, so that we can't break down a square root any smaller than possible. So, for example, I have 3 root 5 times root 10. Now, by simple multiplication without breaking anything down, I would take 3 times 1, which gives me 3, and then root 5 times root 10, which gives me 50. But then I have to look at root 50, okay? And root 50 would be square root 25, square root 2, and then I'd have to break it down. So I go 3 square root 25 times square root 2, 3 times 5 root 2, and the answer would be 15 square root 2. So that is the mixed radical that is in its smaller form, smallest possible breakdown, in which I have no other options with the square root 2 but to leave it as square root 2. Okay, so the other option to do this question, all right, would be to break down root 10 into maybe some of its factors that work with root 5. So what I mean is this. I have 3 square root 5 here. Okay, that's as small as it can go. But I see that root 10 has a root 5 in it, because it's root 5 times root 2. So now I go 3, put it out here. Root 5 times root 5 is 5. And then I'm left with root 2, which is 15 square root 2. Okay, so it is a little bit smaller, all right? And good to see you on there, girls. Okay, so I can do it either way, it still works, but it's similar to fractions. Like if I have a fraction and I have 2/3 times 5/8, let's say. You know, you could multiply the top, you get 10 over 24. But I would much sooner go to, that goes to a 4, 1, and end up with 5/12. To me, making math easier is a lot better for myself. So that's why I would maybe break this down a little bit. But either method is still going to be good for yourself. Okay, so let's look at the second example then. Again, last week when we talked about this, we talked about restrictions. So you'll notice in working example 1b, that they put that x is greater than or equal to 0. That means that you can't have a negative value x, all right? We need those restrictions in there so that if we were to graph them in grade, like we do in grade 12, we'd have domains on them. So anyways, I've got 4 square root 14x times 2 square root 7x cubed. Okay, and x is greater than or equal to 0. There's my restrictions. All right. So again, you can break it down Now I'm looking at this and I'm saying to myself, all right, I've got 14. Well, 7 goes into 14. It could be root 7, root 2. So I could do it that way. To me, that's easier than trying to find out factors after the fact. So I'm going to do it that way. So I'm going to go 4 root 7 root 2x times 2 root 7 x cubed. Okay. 4 times 2 is 8. So I multiply my, now here's 1. The square root of x times the square root of x cubed. So I'm just going to write it below. Now, what you're going to find is I'm going to get messy with this a little bit. I like to write things just so that I can have a visual. So x times x cubed is x to the 4th. The square root of x to the 4th, just to refresh your memory, is like saying x to the 4th to an exponent 1/2. Exponent to an exponent, I multiply, so 4 times 1/2 is 2. Long and short of it, this is x squared. And then what am I left with? I'm left with square root 2. Okay, multiply this together, 56 x squared root 2. Now it is kind of messy. It is kind of messy. It's not super clean. But I'll show you in a second how to do it the other way. Maybe you like it. Maybe it seems cleaner to you. So I took the root 7 out because I knew root 7 times root 7 was going to give me 7. Root 2x I can't break down. 7x cubed I leave. So I should have maybe done this. Sorry. I could have done this possibly. Root 7 times root x cubed like that. Okay. Same thing here. I should have maybe done that. Break them into its parts. Okay, then that makes a little more sense. So I've got 4 times 2, which is 8. Root 7 times root 7, which is 7. Root x times root x cubed is x squared. All right. And then I had, where did I my root 2 here stayed as root 2. Okay. So a little bit faster to do that. All right. Okay, now we're getting into the distributive property now. So I have square root 3 minus 5 square root 10 plus square root 6. Okay, so distributive property means then that I have to multiply this through the brackets. So the first one is root 3 times negative 5 root 10, which is going to give me negative 5, because that's a 1 here. So 1 times negative 5 is negative 5. Root 3 times root 10, root 30. Add root 3 times root 6, which is square root 18. Okay, now I have to look at root 30 and I have to look at root 18. Root 30 can't be broken down. There's no perfect squares that goes into root 30. Root 18 can be broken down to square root 9, square root 2. So I go minus 5 root 30 plus root 9 root 2. Again, I'm writing this out so that you can see all the steps. But realistically, you could probably have just written 3 root 2 and I know what you were doing. So I've got 5 root 30 plus 3 root 2. And there's my final answer. Okay. Again, basically, all that I've added in from grade 10 is just the multiplying of the roots. At this point right here, you did that last year. Break it down and then break it down. That was all last year's work. This year, so far, we've got to just multiply now. And you can only multiply a square root by a square root, and you can only multiply a whole number by a whole number. All right. You know what? If I'm going too fast, just write a comment in there. Okay. Now the next one is FOIL, because I've got a binomial by a binomial. So 5 square root 2x plus root 5. Negative 4 root 2x plus root 5x. Like that. All right. Okay. So the one thing that this has, it's a lot of work. Okay. There's no real fast, simple ways of going through these. So let's start with the first. So the first is 5 times negative 4, which is negative 20. Root 2x times root 2x. Well, that's 2x. So square root 2x times square root 2x is just 2x. Outside, 5 times 1 is 5. Root 2x times root 5x is root 10x squared. Inside, root 5 times minus 4 root 2x is minus 4 root 10x. And root 5 times root 5x is going to give me plus root 25x. Okay? Now, going back to Friday's lesson, I can't add or subtract any of these unless they are exactly the same with their variables. So I'm looking at this, I'm going to break this down, and then I'll simplify. Minus 20 times 2x minus 40x. Root x squared is actually just x. So this is 5x root 10. This is minus 4 root 10x. Can't break that down at all. And then this is 5 square root x. So I have 4 terms there. None of these terms are exactly the same. That's my final answer. All right. And E, I'll just give you a second. Make sure you have that copy down, or I guess you can go back if you need to. Okay, now I'm going to look at E. E works with a cube root, which does not change anything I'm doing, for the record. So that's what I have right there. Okay, same thing here. I'm going to multiply my coefficients. So I've got 7x times 3. Right, different colors. So that gives me 21x on the outside of the bracket. So 7x times 3. And then the cube root, 8 times 8 is 64. X times x squared is x cubed. Y squared times y squared is y to the 4th. Okay? So I've got 21x, which can't be broken down. So I'll leave that as 21x. Now I need to break this down. So I've got cube root 64 times cube root x cubed times cube root y to the 4th. Now again, I don't necessarily have to do this, but in my own mind, I see that it looks a lot sharper, it looks a lot cleaner when I break it into its individual components. So again, I've got 21x here. Cube root of 64 is 4. The cube root of x cubed is x. Now, here's the guy. There's one perfect cube that goes into here because this is actually I find out how many perfect cubes I have inside that. So the cube root of y cubed is y, and I'm left with the cube root of y. So let's tidy this up. I've got 21 times 4, which is 84. X times x, x squared y, cube root y. There's my solution. All right. Again, going through this fairly quickly. Just give you a second there. All right. Dividing. Okay. Okay, again, we look at these restrictions. Restrictions, again, the restrictions mean that if I have a variable, what is my variable? What can my variable not be? Like, so like if I'm solving for equations, I got to understand that I can't put a negative inside the square root as the variable. So that's why they're listed there. Okay. Now, the same thing goes with multiplication and division, is you have to work within the roots themselves. You can't work with a whole number a whole number, a coefficient, and a radical. So looking at this guy, depends on how you want to do it. One way to do it would be to put it into a singular square root. So I have 15xy over 5x. That's one way to do it. Okay, which would then give me, again, I don't need the equal sign. So we can take that out. Just work this way. Okay, so 15 divided by 5 is 3. X divided by x is 1. My solution is 3y. Okay, as long as it's a square root divided by a square root, I am able to do that fairly quickly. Okay, so now I have 8 root 5 over 2 root 3. Okay, again, work with your whole numbers first. So 8 divided by 2 is 4. Root 5 divided by root 3. I can't divide those two values. Now, last year we talked a little bit about this, but not much. This year we are going to have a primary focus on this. One of the things that we don't want to have is we don't want to have a square root on the denominator of a fraction. So what we want to do is we want to rationalize the denominator. So I'm going to show you two very, very important skills here, using B and C as my examples. Rationalizing the denominator means this. I multiply the denominator by whatever the rooted value is. But whatever I do to the denominator, I have to do to the numerator as well. So I'm going to multiply the bottom by root 3, and therefore I have to multiply the top by root 3 as well. This is what we call rationalize the denominator. The reason that we do this is we don't want a square root on the bottom of a fraction, just the same as we don't want a 0 on the bottom of a fraction. But this way I can get rid of it. If you, root 3 divided by root 3 is just 1. So all I'm doing is changing how my fraction actually looks. So root 3 divided by root 3 is 3. Square root 9, which is 3. 4, and root 5 times root 3 is root 15. That's how you want your final answer to look, in which you don't have a square root on the bottom of that fraction. So I have 4 root 15 over 3. Okay? This is what we call rationalizing the denominator. So I'm going to, let me give you a different one. This is not in your book. I'm just going to show you another one. Okay, so if I had 2 root 7 over root 5, all right, I want to get rid of the square root on the bottom, so I multiply the top and the bottom by root 5 over root 5. By multiplying it, so root 5 times root 5 is just 5. And on top, I would have 2 square root 35. And that would be a simplified solution in this case. Okay, so when I have one rooted value, one rooted term on the bottom, I just multiply it by itself in order to get rid of the rooted value. Okay, the next part is what happens when I have 2 terms on the bottom. That's not even close. 2, 5 root 3 minus root 2. Okay, so I need to simplify this fraction and get rid of my rooted values on the bottom. Okay, now I'm going to use a couple words here. I want to multiply by the conjugate of this. I want to multiply by its additive inverse. I'm going to show you what both of those mean. It was something we've already done. We talked about difference of squares in the last 2 units. A squared subtract b squared, which works out to a minus b times a plus b. So a minus b times a plus b gave us a squared subtract b squared. The additive inverse of a plus b is a subtract b. The additive inverse of a subtract b is a plus b. So if I multiply by the additive inverse, I end up with a squared subtract b squared, which then makes that a perfect square, and this a perfect square, which ends up getting rid of my rooted values. So let's try this. I'm going to switch this question just for a second. I'm going to take the 5 out of there just for a minute. So I don't want it too complicated to start with. So the additive inverse of root 3 subtract root 2 is root 3 plus root 2. And again, whatever I multiply on the bottom, I have to multiply on the top. So on the top, I'm left with 7 root 3 plus root 2. I'll worry about that in a second. On the bottom, a minus b, a plus b. A squared subtract b squared. I end up with my difference of squares. 7 root 3 plus 7 root 2 on top. And on the bottom, I have 3 minus 2. Root 3 squared is 3. Root 2 squared is 2. Answer to this would be 7 root 3 plus 7 root 2. Now I took that 5 out of there. I'll show you. I'll put it back in a second. You have to multiply by the conjugate, which is root 3 subtract 2, root 3 plus root 2. And that gives you difference of squares, which allows us to get rid of our square roots. Okay? So I'll do that example again. This time I'll have the 5 in there because it doesn't change much. I just didn't want to confuse you. So let's subtract root 2. So I'm going to multiply it by 5 root 3 plus root 2 over 5 root 3 plus root 2. Okay, so that gives me 7 times 5, 35 root 3 plus 7 root 2. And on the bottom, I have 5 root 3 so I have 5 root 3 squared, which is 25 times 3, subtract 2. I also have to square the 5 and square the root 3. Okay, so on top, I'm left with 35 root 3 plus 7 root 2. And then I got all of that over 73. Okay. This is what we call rationalized in the denominator. This will be in this 5.2. This will be the toughest part of your section, is multiplying by that right there. All right. Okay, and the last of that example 2 is a cube rooted one. So I've got the cube root, 8k over 3. Okay. That little box says, why are there no restrictions on k? Well, the reason there's no restrictions on k is I can have the cube root of a negative number. So k can be any number. And this only works if the rooted value is an odd number. So the square root of the cube root, the 5th root, the 7th root, etc. If I have an odd value here, I can have a negative value in there. So can I divide 8 by 3? No. Can I take the cube root of k? No. But I can take the cube root of 8. So this solution becomes 2 cube root k over 3. All right. Okay. So that's all of 5.2. Five 5.3 works on actually solving questions using radicals. It's actually not very tough. All we have to do is square values in order to simplify. But I'll worry about that on Wednesday. So if you can get completed to the end of 5.2 for Wednesday. Now, ideally, we would be doing a lesson a day, but because we're in the situation that we are, we're going to look at doing about a lesson every 2 days now, to give you an idea of what to do. So those of you that are online right now, I see there's about 5 or 6 of you. If you can put a comment in there and you have questions from your first unit that you did on Friday, I can answer those. I'm going to start at 10:30. I'm going to do the grade 12. I'm going to do the grade 12 lesson. And then at about 11:30, I'm going to come back on here and answer any questions. But you have about 13 or 14 minutes here if you want to ask any questions. I see a couple of you are on here. So either comment on here. If you have a question, send me a message in Edmodo. And if you have my number, you can text it or you can email me if you have any questions from 5.1. I'll answer those right now. So if you're on here right now, you can ask questions if you have any. Okay, if you're okay with 5.1, just give me a thumbs up on the likes so that I know that you were okay with it and you don't have any questions. Okay. All right, I'll stay on here for a few more minutes just so you have a look at 5.2. If you have any questions, or 5.1. Even if you want to comment as well, just let me know how it looks. If it's streaming okay, there's if you can read the board fine, let me know if there's anything I can fix. I think some of the word problems maybe on page 196 to 198 might have caused some issues. Okay, I'm going to sign off on this for now. I'll be back up right away with the 12s. So at the end of the 12s, if you guys have any questions, feel free to chime in at any point when I'm done. It won't take me very long. So probably around 11 o'clock, I'll have, I can answer more questions from you if you have. So again, you can text them, you can send comments, you can comment through Edmodo, whatever works, or send an email. Okay? All right, good luck. We'll talk to you. I'll be back on, like I said, right away.